What is the idea of going from enjoying a diverse diet to needing it?
Well, so we have lots of dietary needs for micronutrients and vitamins and things like this that many other animals don't. And it's a strange thing because some animals can live on very simple, repetitive diets. So I use the example of the koala can be perfectly happy and healthy eating only eucalyptus leaves. Whereas if we had a diet that really was only any one thing, we would be very unhealthy very quickly. And what happens is when you have a diverse diet, which is what our ancestors had, they were really evolving in a salad bowl in Africa with all kinds of different things. And they were foragers by nature, so they were really eating whatever they could find. But lots of variety was sort of built into the environment. Well, what that means is a lot of the micronutrients that many animals have to work hard to create for themselves, they were just served up to us on a platter, so to speak. So when you're always getting these micronutrients in a very rich diet, your body loses the ability to make those micronutrients yourself. So take vitamin C, for example. Vitamin C is something that the vast majority of animals make for themselves in their liver. And it's just not a dietary concern to them at all. They will always have plenty of vitamin C. But we don't. Because we were evolving in an area where vitamin C was plentiful, and this goes way back, not human ancestors. I'm talking about very early primates. There was plenty of vitamin C in their diet already, and so some of the genes that were responsible to make vitamin C got mutated. And things are always getting mutated over evolutionary history. Mutations are always happening. It's like little random lightning strikes all around our genome. Well, eventually it'll hit a gene. And if it hits the vitamin C gene, it's not called that, but there's a gene necessary for vitamin C synthesis, and it has no effect, well, then we don't have to fix it. So that gene just sort of stays mutated. And once a gene gets mutated, it then gets mutated beyond repair. So we have the gene necessary for vitamin C synthesis. It's called GULO for short. But this gene is in our genome. We have it, but it's been completely rendered inoperative by mutations. We could never resurrect it. It's so damaged. It's like a car that's completely broken down in the junkyard. You can tell it's a car, that it used to be a car, and that it used to function, but it doesn't function anymore, even a little bit. And that's the consequence of the fact that vitamin C was in our diet. Well, we have several examples of that, of various things that we used to be able to make ourselves. Vitamin B12 is another one that we used to absorb from the bacteria in our intestine, and we don't anymore because we were starting to get it in our diet. So we lost the ability to extract it that way. And basically our body gets lazy over time. And not for any mysterious reason, just like I said, the random mutations will eventually hit a gene, and if there's no consequence, that mutation will persist potentially. And so what happens is we have this very rich diet that we were evolving in. Well, now we require that rich diet. We need vitamin C. We need vitamin B12. We need vitamin D. We need the right balance of calcium. Calcium is hard for us to get. And so we have all of these things in our dietary needs that other animals don't have because our bodies got lazy at doing these things for ourselves because they were being served up to us in our diet. And why bother making something if you're being handed it all the time?
So in a way, we are sabotaging ourselves. So like right now, we're having, I think, probably the most diverse diet we ever had. So do you think we are basically sabotaging?
Yes and no. I would actually argue that our diet is not diverse in the right ways. So it's diverse in the terms of you might have something different for dinner every night. But what's not diverse about our diet is that the spread of macromolecules and micronutrients is relatively repetitive. And so standard Western diet is way, way overloaded with carbohydrates, for example. So you can eat lots of different things every day, but still not get enough of essential fatty acids, for example. You'll have plenty of carbohydrates, but not enough of certain amino acids and fatty acids. And so our diet's actually most modern diets are actually poorly matched to our needs. Our ancestors really survived on 10 to 25% of their calories coming from carbohydrates. And now something like 75 to 80% of our calories come from carbohydrates. And our body is just really not built for that. So you can eat something different every day, but as long as it's carbohydrate based, it's not really the best diet. And also a lot of the fruits and vegetables that we have cultivated, they no longer resemble what they did in the past. Fruits were smaller and not near as sweet and more fibrous and less fleshy. And you had to eat a lot of them. So, eating an apple that we have now, one apple can provide you with 150 calories, and that sounds like a great thing. Well, it's all sugar and simple carbohydrate. In the past, you would need to eat maybe about 20 apples to get the same amount of calories, and they would have been the size of crab apples now, like small cherries. Yeah. You would have eaten 10 or 20 of those, and you would have gotten all of the micronutrients and a lot less of the calories. So it would have been much healthier to eat 10 or 20 small ones that are packed with those micronutrients rather than these huge ones that are packed with sugar and carbohydrates. Now, I'm not telling you not to eat apples. I'm just saying, in the process of making them calorie rich and better tasting, we also made them less healthy. And that's true for almost every food that we cultivated, from wheat to corn to potatoes. Basically, all of the fruits and even some of the vegetables are much less healthy now and more just starchy. Well, that's what we made them. We made them big and starchy. But that's not really what we need. What we need is micronutrients and amino acids and even fatty acids. We need more of those and less of the carbs.
What about things like all those additives we do? For example, we add vitamin D to milk, we take multivitamins, we take fish oil in tablets. So there's supplements. Right. The market for supplements is booming. And would that be a problem? What do you think about that?
Yeah, most of the supplement industry is a sham. It's targeted in all the wrong ways. Most of those, the things that you're paying for in the supplement, you're not going to absorb anyway, and you have plenty of. And so you don't really need to eat that much in terms of fruits and vegetables to get enough, say, vitamin C. You really don't need that much. You don't need, same with vitamin B12, you don't really need, as long as you eat some meat here and there. And for vegans, they can eat seaweed or they can take supplements. There's easy ways to get micronutrients. The supplementation that does make a lot of sense, for example, is the vitamin D that they put in milk. That makes sense. And the reason why is vitamin D is a very funny vitamin. It's not a micronutrient in the usual way. It's actually a signaling molecule. It's more like a hormone. And what it does is it helps your body. It tells your body to absorb calcium. And so if you drink a lot of milk, you get the calcium. But if it's not absorbing that calcium, the calcium just moves right through you and you don't absorb it. So vitamin D helps you. It helps tell your body to absorb the calcium in your intestine that you've just ingested. So vitamin D couples very, very well with milk. That's not a waste. That's a good idea.
Yeah, of course.
So that kind of supplementation makes sense. Iodine supplementation in the salt makes a lot of sense because you need very, very little iodine. But if you don't get it, then you can't make thyroid hormone. So those kind of supplementations make a lot of sense. And those are the ones that are driven by public health scientists. The supplement industry, with tablets and so forth, that's really not. Most of that, in almost all cases, is overkill. The only supplements I think that sort of make sense are those for vegans to make sure that, or those on restricted diets who have to make sure they get certain amino acids. Even the fish oil fatty acids, they've shown some promise in studies regarding heart disease, but by and large, if you just eat some fish every now and then and other more lean meats, you'll be fine.
The question I have is, do we make it harder for us to, let's say, synthesize calcium efficiently because we are used to have it with vitamin D, so that makes it easier. The question if we are again, sabotaging ourselves in the future because it's going to get harder and harder for us to have it without vitamin D.
Right.
You see where I'm going with this?
So in that case, you chose the example that doesn't make your point, I think. So actually, the answer is no to that. So we need a ton of calcium, and we need the help from the vitamin D to absorb it. And if you sort of restrict yourself from vitamin D, does that help you better at doing it on your own? The answer to that seems to be no. But for other micronutrients, it is true that if you're constantly taking multivitamins, you do lose your ability to extract those micronutrients from your food. And the reason why is that the receptors, when they're overloaded, your body, because you need specific transporters in your intestines that actually pull that stuff out of the food. Well, if you are overloading those with these supplements, then the receptors themselves get fewer in number because your body thinks, we've already got plenty of this. There's no reason to have all these receptors. And so basically, in a sense, you sort of get hooked on those supplements by down-regulating all those receptors. So really, you don't want to take supplements that you don't need because you will lose the ability to extract those from food. And at the very least, take lower dose supplements, don't overdo it, and then also take them with food, so at least it gets diluted a little bit through the volume, the bulk of the food and drink that you have. So at least you're not experiencing a really high concentration. And also, a lot of those vitamins, when you take them at high doses on an empty stomach, they're very nauseating, and for good reason. You're just overloading a lot of those receptors.
Fascinating. Thank you.